On to question 5. We've got electromagnetic waves now. Which type of electromagnetic wave has the shortest wavelength? And that's gamma, which, as you should know, can be written like that. State one difference between ultraviolet wave and a visible light wave. Well, you should know the EM spectrum in order from shortest to longest. So the shortest is gamma, then you've got X-rays, then you've got ultraviolet, then you've got visible, then you've got infrared, then you've got microwave, and then you've got radio. That's what you should know. That's not the answer to this question. But state one difference between ultraviolet and visible. Well, you can say that ultraviolet has a shorter wavelength. You could also say that it has a higher frequency or a higher energy, but shorter wavelength is probably the simplest bet. So, EM waves travel through space at a speed of 3.0 times 10 to the 8 meters per second. If you're not sure about standard form, that's 3 with 8 zeros after it. So 3, 0, 0, 0, 0, 0, 0, 0, 0, that's 300 million meters per second. Radio waves have a wavelength of 25 meters. Calculate the frequency of radio waves and use the correct equation from the physics equation sheet. Well, that equation is V equals F lambda, where V is the velocity or the speed, F is the frequency, and lambda is the wavelength. So you want to find out the frequency, so you need to rearrange that equation to frequency equals velocity divided by wavelength. So in that case, you've got 3 times 10 to the 8 divided by 25 meters, and that comes out at 1.2 times 10 to the 7, and the unit for frequency is hertz. You could write 12 million, that's 1, 2 with 6 zeros after it. You get you're going to get 1 mark for the unit, so don't forget that. Scientists use a radio telescope to measure the wavelength the radio waves emitted from the galaxy. Scientists measure the wavelength as 25.2 meters. The effect causing this observed increase in wavelength is called redshift. Most galaxies show redshift. What it tells? Well, the redshift, don't forget, is the wavelengths are slightly longer than they were before. So it started off at 25 meters, that's 25.2, it's slightly longer. What does that tell us about the way galaxies are moving? Well, redshift tells us that galaxies are moving away from us. You could say away from each other, away from us. The size of redshift is not the same for all galaxies. What information can they find out? Well, the amount of redshift can tell you, one, the distance something is from the Earth, and secondly, the speed that the galaxy is moving. So 1 mark for distance, 1 mark for speed it's moving. And what does observation of redshift suggest happening to the universe? Well, if we look in every direction around the Earth, we see that there's predominantly redshift. As galaxies are moving apart from us, and they're also moving apart from each other, it implies that the universe is expanding. On to question 6. About half of the UK's electricity is generated in coal-burning power stations and nuclear power stations. Coal-burning power stations and nuclear power stations provide a reliable way of generating electricity. What is meant by reliable? Well, it's that you can say that the energy source is constant, or they can generate all the time, or they don't rely on uncontrollable factors. So, for example, wind turbines need the wind. You can't control that, so they're not reliable. So you could say that they can generate all the time, or that they're a constant source of energy. Over the next few years, most of the older nuclear power stations in the UK will be closed down, and the process of decommissioning will start. What is meant to decommission? Well, it's not just knocking them down or shutting them down. It's that you have to dismantle and remove all the radioactive waste and material that's left behind. So the reactor will be still radioactive, will still be dangerous, and that has to be taken apart and stored. So it's the dismantling and removal of radioactive waste materials. Climate change has been strongly linked to the emission of carbon dioxide. Many governments are committed to reducing carbon dioxide. Generating electricity can increase carbon dioxide emissions. Companies generating could reduce carbon dioxide emissions. You have two ways that you can use this. Well, carbon dioxide mostly comes from the fossil fuels. So you could say, well, Mark, reduce the use of fossil fuel power stations. Or you could say use more nuclear power. Or use more renewable energy sources. Or you could say make power stations more efficient. Or finally, you could say use a carbon capture technology. So some power stations will try and capture the carbon dioxide and store it in a different form. But to reduce fossil fuels, or use more nuclear power, or use more renewable, or make them more efficient. What are the possible answers? Word D. Electricity is distributed from power stations along the national grid. The voltage across the overhead power cables of the national grid need to be much higher than the output voltage. Explain why. And for 3 marks. So, first mark, increasing the voltage reduces the current. Secondly, that reduces the energy loss, or the power loss. And the third mark, well, that increases the efficiency of transmission. So, decreases current, reduces energy loss, and increases efficiency. They're the main points. Finally, on to question 7. According to kinetic theory, all matter is made up of small particles. The particles are constantly moving. Diagram 1 shows how the particles may be arranged in a solid. 1 kilogram of gas has a much larger volume than 1 kilogram of solid. Use kinetic theory to explain why. Well, as you know, if you're drawing the same sort of diagram but for gas, you'd have the particles much further apart and they'd be flying all over the place in different directions. So we're looking for 4 marks here. So we need to compare the difference between the gas and the solid. So what causes the solid to stay close together? There are strong forces of attraction between the particles and the solid. So you can mention there are strong forces. They hold the particles together or hold them in a fixed position. You could say that in the gas, the forces are much weaker or are negligible. You can ignore them. They're so small. Basically very small forces. And so the particles spread out. So in a solid, you've got strong forces, hold particles together. I know it's hard to read, sorry. That's in a solid. But in a gas, it's very weak forces. So the particles spread apart. They fill the container. Diagram 2 shows the particles in a liquid. It's evaporating. How can you tell from the diagram that the liquid's evaporating? Well, you can see these particles that are moving away. The particles are leaving the liquid. That's what the evaporation is. So particles are shown leaving the liquid or leaving the container. The temperature of the liquid in the container decreases as the liquid evaporates. Use kinetic theory to explain why. It's important to remember that these particles, the ones that have left, they're the particles with the most energy. The ones that have left are the ones with the most energy. So some will have lower energies, some will have higher energies, and that all averages out to give the overall energy of the liquid and the temperature of the liquid. So the particle, so you get 1 mark for basically saying that the particles with the most energy have left the liquid. That means that the mean or the average, the mean or average energy of the remaining particles goes down, and the lower the average energy, the lower the temperature. So, to recap that, the higher energy particles are leaving. These other particles that are left behind have less energy than these ones. So the average or mean energy of the liquid decreases, which means that the temperature of the liquid decreases. And that's the end of the paper.